Hello, we're going to talk about the second phase of the about advanced data warehouse project, which is a data warehouse development of for a publications database. So the agenda we will have for this presentation is first we're going to talk about the data quality process. After that, we'll see a goal question metric analysis performed. And then we will talk about the issues, the quality issues on the data sources, along with the assessment and correction plans. Then we'll have a look on the ETL architecture used to create the data warehouse, and we will finalize with a roadmap and the task distribution. So before we start with the data quality process, we want to show an overview of the architecture used for the data warehouse creation. So first of all, we have 5 different data sources. Um, Two of them, which are the DBLP and BDTLN data sources, are MySQL databases, and we also have the Microsoft academic graph, the core and HAL data sources, which are flat files. So initially, we'll take all these sources as an input for the talent data quality tool, in which we will assess of the quality and detect all the quality issues that are present in each of them individually. After that, we will use the SSIS tool to correct this data and store it in a staging area. So in the staging area, we will contain a map of these sources, but only containing clean data. So after that, we will use once again the SSIS tool uh, to do an ETL process to this staging area and then generate the data warehouse, which is specifically all the dimensions and facts that we previously mentioned in the first phase during the DFM presentation. So now we're going to talk about the data quality process.
Okay, for the data quality process, we have 4 steps: assessment, diagnosis, correction, and prevention. So first we will do the top-down analysis of data quality, and then we determine the factors to be measured, develop the appropriate metrics and methods to measure and correct them. After that, we will process for every sources before loading the data in the staging area, as we mentioned before. So the next one is the GOM question metric. To analyze data quality, we use GOM question metrics to define the factors, the object, and the metrics of the problem we need to correct. First of all, we define the goal for which is the highest level of purpose we want to tackle the quality problems. And we focus mainly on 3 main goals. First is the authors, next is the publication, and the final is the venues. With author, we define the question related to the author name, author country, and the institution. For example, we have the question like, do we have the same author repeated in our data? And for this kind of question, we will focus on the unique factor in the name of the author. So we will measure by the rate of duplication in the author name. The next one is like the author name is written correctly in the data. This one we will answer by detect the correct format of the author name, and we use Boolean metric to do this. So if it is written correctly in the data, then it should be 1 for the metric, and the otherwise is 0. And related to the author country, we require it to be in the right level of data. For example, like we don't put the city or the town instead of the country. So we will measure the ratio of wrong levels tables in the country of author. Another one that we require the completeness in the institution of the author. Like we need to have we require that the on author have a university, and this one will be measured by the ratio of null or blank value of the author in the university. The next goal is the publication. We will focus on the author ID, the venue, the title, and published date of the publication. For example, we will define some question like the duplicate do the we have duplicated publication, or do the publication is written correctly, like before we define with the authors. And we also require the published date in the publication in the right level, like we will put the full date, month, year, and date, month, year instead of only month, year, something like that. And this one should be answered by the ratio of tuples which are not expressed in the full date in the dataset. The final goal is the venues. Venues is the conference and the journals in the data source. And we focus on the duplication in venues, and the name of the venue should be written correctly. These things should be measured by the ratio of duplication in combination of venue, name, and author. And we also consider about the country of the venue. It's like the country in the publication. It should be in the right level of detail. And this is considered as the precision of accuracy. The final question is do we have rank upon values? And this is the factor should be the completeness of density on the value rank. So we will measure by the ratio of null and blank value in the value rank. And the next.
Okay, let's talk now about the data quality problems we found in each one of the data sources. In order to perform the analysis on each data source, we use Talent, data quality software, in order to make all the aggregations and to be able to measure the accuracy, completeness, consistency, and uniqueness dimensions of our datasets. So the first one is accuracy. For accuracy, we will start describing the syntactic correction factor, then semantic correctness, and then finally precision. So for syntactic correction, we will show examples of the errors we got in each one of the data sources, but we won't show all the analysis we did. The first one is the BDTDN database, which is the one that had the most quality issues regarding the syntactic correction. Why? Because all of this database was in French and the expected data was in English. The image shows the country of publication, and as you can see, the country of publication is written in French. So this was our quality problem. So now to define how to correct this, we downloaded a file containing all the names of the countries and their ISO codes, both in French and in English. And later, using the we use a ETL script to match a country written in French to a country written in English, and then just replace it.
in order to correct the problem that I just described, we created an ETL script that will replace the country that is written in French for the country that is written in English in the ISO code. In this part, we can see part of the ETL that we used to correct the problem, and in the right part, we see that the problem was corrected when we query the staging that was already loaded. We see the country already written and normalized in English. So now let's talk about semantic correctness. In BDTLN, we also had this kind of problems. This one was a table directed only to cities, but in this table we had also countries. So this was a semantic correctness problem because we had entities that does not correspond to what the column was describing. So in order to correct this, we did an ETL really similar to the one that we created for the step before, that mapped each country to each city to each country. Okay, now let's talk about precision. We found examples of this quality problem in many data sources. This one specifically shows a precision problem in the HAL database. Why? We have the procedure date of the publication, and we see that we have the date with day, month, and year, and for other publications we only have the year. So this problem was also seen in BDTLN. As you can see here, you see the pattern of all the dates found in the publication table. We have patterns where we have only 4 digits, only where we have the digits of the year and the month and the day, and some of them that are empty. So in order to correct this problem, we just for in the first case, we create an SQL script in order to cast the date and transform it into a date. This date that was with all month and day, just to do it in year. And for the second part where we have year, month, and date, like it's in here, we just got the string. We just got the first 4 strings, and the problem was solved, as it can be seen in here, where we have the all dates and the date that we insert into a staging area.
Okay, so right now let's talk about factor completeness. In this case, we have some examples, such as in this data source core, we expect to have the ranking for all conference and journal. However, we don't have also in the staging, we do not insert conference or journal in the blank rank. So that means that in the staging, in the ETL, we don't have that tuple in our data warehouse. So now we can see that in the data quality, the conference rank, we have 5 blank, and after we don't have any.
Let's talk about the consistency, specifically about the domain integrity factor. After having analyzed the data of BDTLN, we realized that the data of the author country should be in collaboration. The author country was organized in two different columns. The first one was collaboration 1, which indicated whether we were in a city, in a country, or in other two different values called labo and team. We discovered that all of the tuples in ville belong to cities of France. This is shown in this graph. All the ville, you see, are all cities from France. So in the ETL, whenever we find a collaboration wall called ville, we will automatically deduce that the country will be France for this data source.
Okay, we are going to talk about the uniqueness data quality factor. We have some issues with our data source. One of them is core, for example. We have some conference and journal duplicated. As well, in the case of microacademic data, we have problem with author. We have some duplicated author, and we got the solution in ETL part. One the solution is compared with the paper author affiliation table, and we will discard the author that don't match in that relation table in our staging area. The problem with deleting author or discard in this case, before checking into the relation database, is that those duplicate paper have different paper ID. So we cannot discard or we cannot delete before try to match in our relation database. Another example of uniqueness factor quality is the conference that in Microsoft Academic Graph. In this case, we have some conference instance duplicated, but is duplicated only in the ID in all attribute except in conference ID. So we solve in ETL part in lookout or sort in our conference instance. We will need to decide which one we will delete. So in this case, we will take in the tuple that we found ID. Sometimes we don't found conference ID, but we will prioritize when we found data in this case. So this is after correction. So we will see here that the same tuple we don't have duplicated, and we got the conference ID. And as you can see here, sometimes we don't have this value. About correction in uniqueness factor. In this case, for example, we have a small data source, the small duplicated, so we correct manually. And in the other part, we correct in ETL. However, we have to make sure that this method only work with exact match duplication. So we also face some problem. For example, here we have Erasmus Universiteit and Erasmus Universiteit Rotterdam. So we are not sure if it's the same the author in this case, because it is the author that we were talking about in the last example. So if we found different ID, it's difficult to decide if it's the same or not. We only can decide what is match duplication in this part.
So now we're going to talk about the ETL architecture. As we mentioned before, the staging area is loaded with all the clean data, which is the output after correcting all the issues found. So we mentioned previously that we had 5 databases that we are using, 5 sources. So in here we can see what are the staging tables where all the data for each source is mapped. So for example, in the case of Microsoft Academic Graph, we have information about the publications, the author, journals, and conferences. In the case of BDTLN, we have information about the publications and the authors. In the case of HAL, we have information about the conference journals, publications. In the case of DBLP, we count with author and publication information as well. And in the case of core, we have the rank for conferences and journals. So now we're gonna see in detail how the data warehouse development was made. First of all, here we have the control flow of the ETL. So as you can see, the fact tables are mainly generated after having loaded all the dimension tables, and these dimension tables are loaded with the staging tables that are mentioned previously. And some of these staging tables are also the input for loading the fact tables. So to understand this better, we will see in detail one of the dimensions load. In this case, we're going to check the dimension publication. Okay, so this chart corresponds with the control flow in detail of the dimension publication. So as you can see, we are loading information from different sources here, which are the ones that actually contain data about the publications. We're giving priority to the Microsoft Academic Information, which is the most complete database. And what we do next is just from each of the other databases, we take the publications that are not already loaded into the dimension table. As you can see in detail here, this is the data flow. So in the first case is Microsoft. We take it from the staging that corresponds to Microsoft source. Then we see if the information contained there is not already in the dimension publication table, and we proceed to insert it. Then we do the same with the DBLP, and so on with the rest of the sources. Now, in this chart, we have the detail of the control flow for the fact publication table. So once again, we have to take information from 4 different sources. Now here in this table, we have the detail of the data flow used to load the fact publication table. So this first case is for Microsoft. So the first step is to load the publication and author relation from the staging table of the Microsoft database, calculate the number of authors for the staging, and then we correspond to do the necessary lookups to bring the date and venue and author information and the dimension publication as well. And we finally proceed to insert this into the fact table publication. So as in the previous case, we proceed with the next source. So let's say in this case, this chart corresponds from the DBLP. The data flow is pretty much the same. So in this case, we will load all the data that is contains all the publication and author relations that are contained in the staging table that correspond to the DBLP table, and so on.
Okay, let's see. The last part is the task distribution. As you can see, Jorge do the first part of data quality assessment and correction, ETL of initial load of the data source into staging area. Gledys do the Microsoft Academic data quality assessment and correction and so on. And Thao do the core how data quality assessment and correction, and also the ETL part. As for Juan, he did ETL of initial load in the data warehouse, SQL script for staging database, relational database for OLAP. As for Tzu-Jou Hsiao, should do the default data quality assessment into staging area and correction part. And thank you for your listening. This is the end of our presentation.